Amanda Miles. I'll introduce you. I don't see Dr. Kaya.
Oh, it's totally fine.
Okay, great. And we actually have two that kind of come together later on when Marcus is going to talk. So it's sort of interesting. It's a graduate and an undergraduate. It's a psychology experiment. It's a data management technique. So this has really been an extremely unique collaboration among different students and the research that's going on. So Amanda, take it away.
All right. I'm actually going to have my own timer so I don't go over too badly. So hi, I'm Amanda Miles. I'm a graduate student in the Behavior Analysis Department. And Dr. William Kaya is actually my supervisor for this project. This is a thesis project. And Mr. Marcus Shell, which you will see later. Like a lot of these data figures that I'm going to show you would be completely impossible if he hadn't been helping me. So I'm going to go over my thesis. Again, it's evaluation of local behavior dependence in static and dynamic environments. And I apologize in advance if it's a little technical. All right, so what is behavior analysis? So behavior analysis is the study of human behavior. What we're interested in is how do we change the environment in order to change behavior. So some applied examples you might see would be a practitioner working with a child who's been diagnosed with autism to decrease problem behavior and increase appropriate behavior. So my question is more of an experimental analysis, which means I'm interested in looking at the underlying basic behavioral principles that govern all behavior, so more general. And that's one of my pigeons that I taught to play ping pong. All right, so briefly, if you've heard of behavior analysis, you might have heard of schedules of reinforcement. So schedules of reinforcement are actually going to be not as important as you might think, but they are very clear and well-documented examples of how you can change the environment or things that are experienced in the environment to change the actual behavior. So a lot of these schedules that I'm going to show you are actually, they just tell us how we can get a particular pattern of behavior. So if I arrange the environment in this particular way, I get this behavior, and in this way, I get a different type of behavior. So one of my manipulations in my experiment actually involved variable interval schedules, which means that the first response after an average amount of time has passed is going to earn a reinforcer in the form of food, because these are pigeons. So I use 3 different distributions, and the distributions are, so they're going to have the same mean value of when a reinforcer is delivered. The only difference is where these reinforcers are actually being delivered. So these lines right here are going to tell you when a reinforcer delivery is going to happen. So in the Fleschner-Hoffman is a constant probability schedule. You have some short delays and you have some long delays. The wide rectangular distribution looks like this, anywhere from like 0.5 seconds to 40 seconds. And the narrow rectangular is going to look like that. So this actually looks more like a fixed interval than a variable interval because you've got that pause right there at the beginning. So I had 4 different groups of pigeons, 3 pigeons per group. I had 2 in the Fleschner-Hoffman distribution that were assigned to the Fleschner-Hoffman distribution, and that was sort of, so I started one on the static procedure and I started the other one on the dynamic procedure as kind of a control for order effects. And I think that's all I had to say about that, actually. So this is what the static and dynamic procedure look like. So the static procedure is constant exposure, no changes whatsoever in the contingency of reinforcement. So whichever VI distribution the group was assigned to, that was all they experienced throughout the entire procedure. For the dynamic procedure, it's actually a little bit different. So these shaded bars are actually where they're being exposed to the VI distribution, but these flat lines is going to be when they're exposed to an extinction. So there's no reinforcers going to be available to them at all in this period. And the dynamic procedure had 3 identical trials, and it lasted about 1 hour and 40 minutes. So the reason that this is important is this dynamic procedure is actually going to be a very complex environment. So normally in everyday human interactions, we're not going to be experiencing the static procedure. It's just not going to happen. We are constantly being exposed to different contingencies or changing contingencies, and that's what this dynamic procedure was kind of set up to map. So some of the analyses I was interested in is this first pulse the same as what's happening in the second pulse? So are there any differences? And also, is the first trial different from the second trial, different from the third trial? So this is very important because if it's not the same, then I can't treat it as if it's the same. I'm going to have to analyze it as if it's something very different. Another thing I was interested in is, so the static procedure and what's happening in the pulses are the same exact contingencies. These are the exact contingencies that this bird's experiencing. So can I say what's happening in the pulse is the same as what's happening in the static procedure? A few other analyses I was looking at. So in a dynamic procedure, I wanted to know if what's happening before the first reinforcer delivery the same as what's happening after that reinforcer delivery. And I was also interested in what's going on in these extinction periods. So this is a lot of different things that I'm able to analyze with this setup. So here's some data very briefly. So this is going to be the overall rate of responding in all of the pulses of a dynamic procedure before the first reinforcer is delivered. So it's pretty variable, if you can see, very up and down. If you look after the reinforcer delivery, it's not variable at all. So I have to treat what's happening in this pulse differently, whether it's before or after that first reinforcer. So if I'm looking just at the after reinforcer, this is the first pulse combination and the second pulse combination, and they're pretty identical. And this is the first trial, second trial, and third trial. And again, they're all pretty identical. So after reinforcer, it looks like I can just combine all that and treat it as the same because it is pretty much the same. Except, so before reinforcer, this is the first pulse, and this is the second pulse in that dynamic procedure. And this is the first trial, second trial, third trial. So this is very different. So before reinforcers, I can't just combine. I can only do that to the after reinforcers. There's a clear effect, and this is systematic across all the birds. I'm showing you one right now, but this is a clear trend where the rate actually decreases as the session progresses. So each trial that they're experiencing, there actually is a decrease in rate, which is important to know. I'm not really sure why, but it happened. So if you look at the rate in the static procedure versus the before reinforcer in a dynamic procedure and the after reinforcer of that pulse in the dynamic procedure as well. So this is another very interesting thing to note. So I was expecting what was happening in the after reinforcer of the dynamic procedure to be the same as the static procedure because it's the same contingencies. However, when I'm looking at it, the rate, just the rate alone, the variability is more like that of the after reinforcer than the before reinforcer, but this static procedure was very difficult to actually compare what was going on. So it was neither higher nor lower nor the same nor systematically different in very many ways. So I don't have much that I can say about that, which was very strange. It was very unexpected. Okay, so this is going to be very briefly broken down. I know this looks like a lot, but bear with me. So this is the inner response time, so the time between responses. And on this axis is going to be the inner reinforcement interval, so the time into the interval. So each of these dots, that's a response. So this could have thousands of responses from these pigeons plotted on the same plot. This is a lot of data. So as the pigeon is responding, so time is ticking along, it records a response and it resets, and then it does it again and again and again. And when a reinforcer is delivered, it resets back to this axis and starts the process all over again. So every time a reinforcer is delivered, it resets and it starts again. These bands are characteristic of the bird. So we found that pigeons, when they're responding, they kind of respond like a metronome, kind of. They just keep the same type of movement. But if they miss the response key and they're not actually hitting it, then the time keeps ticking along, and then the next time they hit it, it records a response. So this actually tells us a lot about the behavior of not just pigeons, but behavior in general. But it is very interesting to look at. So if you take all of these responses and move them to the top, this is a count of the responses, the number of responses at each time into the interval. And if you move all of these to the side, this is going to tell you the frequency of that inner response time, so how often that time between responses occurred. And so all this is very useful information. So some examples of dot plots that I can show you. These are both Fleschner-Hoffman dot plots, different groups of pigeons, but this is just, I wanted to give you a brief overview of what they look at like. And I'm actually looking at this pattern of behavior right there. And then this is an example of the narrow rectangular and the wide rectangular. So this right here, there's pauses at the beginning before there's much responding. And then this, of course, right here. This is actually telling me a lot about the behavior. The reason that there's white space right over here is because whenever there was a reinforcer available, the pigeons earned it pretty quickly. So there wasn't any responding occurring out here because nothing was recorded. And finally, very briefly, this is what I'm currently looking at. So this is the extinction analysis. You know those extinction periods that I mentioned very briefly? This is actually what's happening in the extinction period. So this is the first extinction, second extinction, and third extinction of each trial. So trial 1, trial 2, trial 3. And I was looking at what can I tell about behavior based off of this extinction period? So you would expect there to be a lot less responding in extinction periods because they're not earning reinforcers, but they're actually responding an awful lot, which is strange to me, but it happens. And there's also these those clusters of responding right there. So that's when they're still responding as if they're still in a pulse, and then they stop responding and they pick back up there at the end. So this is my current look, what I'm looking at currently. Just preview. But thank you for watching.